We should be live on YouTube as well. And awesome. Perfect. Thank you, Adio. All right, we're live. Thank you everyone for joining. This is the last day of the Solstice Festival. I am Emanuele Stoppa, a core member of the Astro project, also part of the TSC. And today we're gonna talk about the content security policy, what it is, how it's done in Astro, and we're also having kind of a show off of this CSP in this very website that I built for you guys, which is a kind of also presentation. So it's a kind of a weird setup, but I really like what I created. So let's go. All right, so before talking about CSP, we need to talk about, what's CSP for? And one of the things is this weird acronym called XCSS, which stands for cross-site scripting. So it's essentially a way for hijackers to collect information from website by injecting their own scripts into your website. And by doing so, they can steal information. They can also mine their own cryptocurrency, or like injecting some SQL code. There's a lot of stuff that they can do, and we want to prevent that. And how do you do that? Well, first of all, I want to actually show you XSS. So this is a very raw example of how someone can inject their own script. One of their cases is using the URL, using, in this case, a search parameter. So let's test it for this very case. So as you can see, it's not working. So we have our parameter here in the URL, but it's not happening. Why? Because the majority of the front-end libraries that we use, Astro included, they are actually really good at that. They will make sure that the strings that come and rendered are actually sanitized. However, we have cases where we actually want to render the HTML that it arrives from us. So in this case, Astro allows us to do that with this set HTML that now we're going to use. So we're going to remove what we have at the moment. And there you go. So the web page actually executed the script, and that's a clear example of XSS. There's also another form of XSS, which is data that comes from your backend. So this is an example of a blog post that has comments. So I created content collection at the moment, so I don't have a DB set up. But just wanted to show you that sometimes hackers can do this kind of stuff. So you're gonna try to inject their own HTML with their own script in their comments. And if you're not very careful, well, bad things can happen. So, however, sometimes you want to have a content that is well enriched, as colors, bolds, and things like that. So you want to provide HTML capabilities to your website. So we're gonna do the same as we did before, and there it is. So the script has been injected, it has been executed, and you can say bye to your money. So that's essentially what XSS is all about. Enters CSP. So CSP is essentially one of the solution to prevent this kind of attacks. CSP stands for Content Security Policy and allows you to have a fine-grained control all over the resources that can be imported, used, and executed on your website, such as scripts, styles, images, fonts, everything essentially. So you can read the spec on MDM. It's very powerful. There's plenty. We're not gonna check everything about CSP. We're gonna check just a few parts related to how Astro works. So, in order to understand why we took a long time to implement CSP on Astro, let's check the proposal. So, first, the proposal had a lot of upvotes. It's our most upvoted proposal, and it was open around 2.5 years ago. We took our sweet time, but the problem was that we needed to rethink our internal architecture. Astro provides a lot of great features. It works out of the box for SSR and static pages. However, at that time, the code was quite difficult to maintain. So we had to rethink the whole architecture in order to provide powerful or more powerful features. Eventually, this refactor came to be around 1.5 years. So myself and another core contributor managed to do this big refactor, and it gave a lot of great features out eventually. For example, Astro M, which I suppose you love, Container API, which is still an experimental feature but quite powerful, and eventually CSP. To give you a glance of this new architecture, essentially we created an agnostic runtime that can be run in every kind of environment. It can be static websites, SSR, edge functions, any middleware. So SSR and development. So we had to create an agnostic runtime, and eventually we had to create those interfaces where some stacks, for example, development, build, SSR, could inject their own information. An example of agnostic runtime is essentially when we create the web page, we accept a web standard object called a request. So each stack has to provide this object, and sometimes we don't have it. So the adapters like SSR needs to create it out and then give it to the runtime. An example is Node.js. When you create a web server using the HTTP module of Node.js, you get as a request an incoming message object, which is not entirely a web request. So internally, the adapter creates a web standard object and it passes to the runtime. So together with this agnostic runtime, we also managed to create a fourth stack that is not here, which is the Container API. So the Container API is its own kind of, it has its own limitation constraints, but eventually when it renders the page, it uses this runtime. And CSP uses this newfound architecture. So I gave you a technology background of Astro. Now let's go back to CSP. Now, CSP can be implemented in different ways. One is the Nonce header. It's quite straightforward to implement. As you can see in this example, it's an Express application, but it can be done in any framework. And the concept around Nonce is creating an arbitrary string called Nonce that is created every time you attempt to request to a page. It has to be different at every request, so it can be predictable. If the attacker can predict your nonce, it means that it can bypass the CSP. So in this example, the nonce is created by using the random UID function, and then it's passed as a header to our response. And then this value is also attached to all the scripts of your page, either inline scripts or scripts that import other JavaScript files. As you can see, it's very simple to implement. If you had to do it yourself on, for example, Cloudflare or Vercel or Netlify, you would have your edge function that listens to every request. It generates the nonce, and then it takes the response of the request and it modifies the HTML of this response by injecting the nonce. You would do it with a regex or any libraries that allows you to do a parsing, a walk-in, and a write of the document. So in any case, it's quite straightforward. However, this solution didn't feel like something that Astro would adopt, because Astro needs to work out of the box. It has to provide a seamless experience, and it has to work also for static pages. And that's why we evaluated this solution, the solution of the hashes. So in this example, as you can see, it's very similar to nonce, but the difference is that the hashes are at the top. So they must be known at build time, or when you actually want to serve the page. These hashes are calculated from the content of each script and style that you have in your page. So the second hash is created by this content, and the first hash is created by the content of main.js. Why it is complex? So let's suppose you have a single page application, can be Vue or React, and you would use your React router to create chunks of your routes. So you want to use suspense and do a dynamic loading of the route. When you build your application, you would have different chunks created by your build, and these chunks are imported dynamically during the life cycle of your page. During the build, you have to generate those cycles, those hashes. So at the end of the build, you would have to have access to these chunks, read their content, and generate the hashes. And then your web server will need to be able to read those hashes and serve them. That's why it's more complex. And that's why we think it's a better experience for the Astro users. So eventually, that's how the feature came to be. So it's a simple CSP through under the experimental flag, and there it is. It works out of the box. So our hashes are served. They are not served as the response header, but they're served using the meta tag in the HTML, so in the header and the head of your page. As a content, it has the same content that you've seen before. So the CSP protocol allows you to serve these headers either as a response header or HTML meta tag. So like this, we'll be able to support static pages, dynamic pages, and also single page applications. So that's good, right? But you will see that we actually changed a bit our take. Regardless, you also have full control over the CSP header. In fact, we provide many options to you. Like you can change the algorithm of how you generate the hashes. So we give you 3 algorithms because these are the ones that are supported. We give you the opportunity to provide your own directives. Like Astro, as for now, is fine-grained control over script and styles. However, you want to have more control over other resources such as images, fonts, forms. There are many. So with directives, you can do it yourself. But you can also tweak the script and style directives. So you can add more resources or less resources. You can add hashes of scripts that are injected into your website by other third parties. For example, Analytics or Sentry or any other third-party script that is not part of the Astro application, for example. So you just generate the hash, you add it there, and it's added to all your pages. That's right. So these configuration are for all your pages. So, but it's not the best, right? You want to have more control, and that's why we provide also runtime options. So like you want to have your own form that has more control than the, I don't know, a landing page. So in your form, you can add your own resources, hashes, and directive straight to that page. As you can see, it uses the Astro global object, which means that you have the same APIs also in the middleware and in the endpoints. And the name is quite similar to the options that we have in the Astro config, so they are very familiar. They work a little bit differently compared to the static options, but the semantics are the same. Now, as I told you before, our take changed a little bit since we shipped CSP as experimental. So thanks to the incredible feedback that we had, we understood that the first solution didn't cover many of the cases that users needed to support. So now, what's changed? So view transitions, unfortunately, aren't supported anymore. So we dropped the support because we noticed that there were unwanted breaking changes. So in order to support it, we will need to actually break your code, and we don't want that. So we reverted, we dropped the support. We might be able to add it again in a new major, but maybe we don't want that. So feel free to leave your feedback. If you think that client router should be part of CSP, just share it. Or if you think it should be, please share your opinion in the roadmap. Then we decided to ship the CSP header using the response header when you're rendering a dynamic page. So instead of using the meta tag, we by default we changed the logic, and now your dynamic page serves the content security policy header using the response headers. And we also added a new capability to our adapters. They are experimental, but I think you're gonna love it. So in order to ship the CSP to provide this CSP header using the response object, there are some platforms that allow you to do that. For example, Netify and Vercel and Cloudflare allow you to create a configuration file ahead of build, where you can list the response headers that you want to ship when a static page is served. And that's what we essentially do. So Netify, for example, has this feature as experimental, and we're going to see it in action later on for the Node.js adapter. So we want to try to support the majority of the adapters, so no one is excluded. So that's the status quo of the CSP feature in Astro. It's still experimental, so what's next? So we still want your feedback. So you guys are the experts. So I'm sure that you know stuff that we don't know. So please try it and share your knowledge with us, so we make sure to make the CSP even better. We also want to look at try to support the development server. So if you don't know, at the moment, the development server can be supported due to how Vite works in development. If you don't know it, when you use the development server of Vite, styles and scripts are injected inline by default, and the same happens also with HMR, and this essentially goes against CSP. So as for now, if you want to test your feature, unfortunately you are constrained to build your website and then use the preview server or a preview deployment. And we want to allow to give even more control to your CSP headers. So if you think there's something that you can do with what you have today, please let us know, and we will make sure to consider your opinion and make sure that we will be able to provide the options to do that. All right, so let's see it in action. So I'm going to use this website, and I'm going to go into build. Because yes, I mean, I showed you EXXS on this website. I showed you how the attacker was able to execute the script. Now let's go. So first of all, as you can see, styles are actually rendering. So I built this website using Tailwind, and I just want to show you guys that things actually work. So apology for that. So as you can see, we don't have any header because we don't need it probably. We will see it later. I'll show you guys. All right, so we want to go to see it in action. So we were back to the search, and in the search, we are setting the HTML of the test link. And oh, apologies. That's why it was not working. I didn't enable CSP, so still need to remember all the steps. All right, so if you go back to our developer tools, yes, we have it. So as you can see, so this page is served as SSR, so it's a dynamic page. We have our adapter, and it's a server render page, so we have an opt-out, and as you can see, we have all the information needed to render and execute the resources. However, we aren't allowed to execute the script anymore. We have an error, and I bet we have a counter security. Yes, so it's actually working as expected. So that's what we want. Let's go. Yes, it's working. So as you can see, also we had the script here as anonymous, and we should see again our error from the developer tool saying that, oh, this violates the content security policy because we don't provide the hash for that script that was injected in the comments. Awesome. Now I want to show you a real preview of something that we're about to ship in the next minor, which is what I mentioned before, experimental static headers for the node adapter. Now, I want to show you first the setup. So we have this static headers page, 2 pages, and to be more precise, they are both static pages. So we opted in with the pre-rendered true. So they are as you can see also from the build, they are static assets. All right. Now, if we open the network tab and we check again the request, you will see, hopefully, that the content security policy header has been served as a response header. So that's a new feature which allows you to not serve the headers using the meta tag, but a response header. Why we want that? Something that I should have mentioned before. So there are some restrictions where some CSP directives don't work if they are served as a meta tag. This was a feedback from our users. So we decided to give the users the possibility to change and provide the functionality that required. So we can also see that it works out of the box also for the dynamic pages. So this page uses get static paths. So it uses a content collection to generate some pages. The content is different for each page, and we still can see the actual styles because we serve the proper content security policy headers. So let's go back, let's refresh, let's inspect, and there. So this also allows you to, if you really wanted to, you could actually do some if-else to generate and inject custom directives or custom hashes based on the page. It would still work because we generate a unique map where a certain page that is generated during the build is mapped to the headers generated by that page. It's a real like an implementation detail, but I want to show you the actual result. So if you actually need it, it's in this folder. So if you are an hacker and you really want to have this file for yourself and some other resource, is still there. So you can actually have it a go. It's a JSON file. It's really simple. As you can see, we have the Python name generated during the build, and that's the header. And it's very similar to what you would have with other adapters such as Netlify, Cloudflare, Umbrcell. They have their own configuration file. You can provide an information very similar to this one, and they will use it when they serve the static pages. So we actually borrowed their logic. So why reinvent the wheel, right? Okay, so are there any questions from the audience that I actually missed? Okay, does supporting CSP tags with... Oh, that's a really... so this question, does Astro support using its CSP tags with content security policy report only? No, but we could actually investigate and see if we can support it. As I said, like I might not know everything about CSP, so please give us your use case. Let's work it together and let's make it happen. So as far as I know, there is no theoretical limit on the CSP in meta tag, but the others, yes. So that's really a really good point. So response headers actually have a limit of, if I remember correctly, 8 kilobytes. So you have an actual limit. So if you have a lot of hashes, there's a risk that you could outreach that limit. However, you don't have this limit with the meta tags. So it's a compromise situation, unfortunately. But Yeah, it's a really good point. Okay, let's see if there are other questions. Okay, so maybe that's an old question, but they were asking if client router support is actually planned. So the thing is, we can implement it, but we noticed that there were some unfortunate breaking changes. So to make it more technical, when we compile Astro and you use your own the transitions, we generate a function that is synchronous. In order to support CSP, we have to make that function asynchronous because the generation of the hashes has to be asynchronous, unfortunately. Doing that causes some unfortunate side effects around some, like I don't know, function that you might use in the same document, where before they were synchronous, but now they must be asynchronous in order to be working. And this is a breaking change. Like you will need to change. Let's suppose you create dynamically some divs, and those divs have a transition directive. That function must become asynchronous, and that's a breaking change. So I'm not sure if we users want that or are ready for that, but regardless, it's a breaking change. So that's why we reverted it, and we might want it into have it in Astro 6 because it's a breaking change. Okay, let's see. There are questions. I don't see any other questions from the audience. So it's another question regarding the client router. So if you just use a basic client router, no config or transition persist everywhere, would you expect it to work? Yes. However, as I said, like, it's not something that we have control over. We could actually make our compiler smarter because we need to know in advance, we need to tell the user, okay, you can use the view transition only if you're not using any transition persist, essentially. So it's actually quite tricky, but I think it's achievable. Not sure if we need to change the compiler for that, but yeah, it's theoretically possible if you have a bare basic use of the client router. However, I also, during the developments, I also noticed that the client router does some weird stuff that they actually made to bypass CSP. So for example, it swaps scripts when you go from one page to another. It also swaps some header elements, for example. So these are operations that might not be likable by CSP. So that's one of the arguments of why maybe we shouldn't support it, or support it in a limited way. So Martin is our expert in view transitions, so we'll have a chat with him and see what he thinks. If it's doable, worth it, we'll see. Okay, so don't see other questions. I hope you enjoyed the presentation. I really had fun creating the website because it actually uses in a real world. I mean, I made the access happen. So I showed you that our implementation does work. So I hope I convinced you guys. And do you plan on making the demo website available? Yeah, I could make it available if you really want to. It's on my machine for now, but yeah, I could push it on GitHub and actually, funny thing, there are a few things that I broke. Like I couldn't use Tailwind initially. I was like, does it actually work with the Node.js adapter? Well, it turns out it was a me problem, so I made some wrong implementation. So yeah, that's actually very funny because like we are the developers of Astro, but we don't know how to use it. So and I think it's true for well, I don't want to blame Tailwind. I mean, I'm no expert, so I can pass judgment on Tailwind. Actually, I had to use some AI agent to write the styles for me. So I have no shame in telling that. Thanks, Matt. Yeah, I also like that. It's a really weird format, but I mean, for this case, I wanted to do a presentation and also show it to you guys. I mean, it works. All right. So if there are any more questions, I think we can end the stream here. Still, please be around on the Discord. We haven't finished with the festival. There are still few things that we have to announce. So I'm not the last one. I hope you enjoyed the week and the festival and you liked all our streams and the engagement with the community. And I'll see you around. Ciao.